Hello everybody! In this video, we are going to look at a few examples on linear motion equations, also known as Suvat equations. If you haven't watched the video on linear motion equations, I suggest you watch that first. You can click on the link at the top of the video, or you can click on the link in the description down below. Now, if you are ready, let's get to it. Our first example says that there is an aircraft sitting on the runway that is ready to take off. It accelerates at 5 meters per second squared for 10 seconds before it takes off. What is the speed of the aircraft at the moment it takes off? So, just like any Suvat question, the first thing I'm going to do is write down what I know and what I don't know. So I'll list down all the variables. Now, there's nothing here that says anything about the displacement or the distance that the aircraft makes. So I don't have any information on the displacement. What about the initial velocity? The initial velocity is actually stated because it says the aircraft was sitting on the runway. If it was sitting on the runway, that means its initial velocity was 0. Now what about the final velocity? That's what we're trying to find out, right? It says the speed of the aircraft at the moment it takes off. So that is the speed of the aircraft towards the end of the acceleration process. So that's what we're trying to find out. The acceleration is given 5 meters per second squared. And the time that the aircraft took to accelerate was 10 seconds. So now I have U, A, and T. That's 3 of my variables. That's totally enough for me to get the other 2. So I'm trying to look for V. I need to use the equation V is equals to U plus AT. So I'll substitute everything into my equation. V is equals to 0 plus 5 times 10. V will become 50. Of course, remember the units has to be in SI units, and the units for velocity is meters per second. For the second question, a race car starts from rest and accelerates to 60 meters per second. It then starts to slow down before coming to a complete stop. The race car has an acceleration and deceleration of 8 meters per second squared. What is the total time taken? So, we have to split this question into 2 separate parts. The part where the race car accelerates and the part where the race car goes to a stop. So let's do the first part. In the first part, we don't know the distance traveled by the race car, so our S is still an unknown. The initial velocity is of course 0. As the question stated, the race car starts from rest. What is the final velocity? It says that the race car accelerates to 60 meters per second, and that is actually the final velocity. The acceleration is given, same as the deceleration, that is 8 meters per second squared, and the time is what we're actually trying to find out. So I have U, V, and A, and I'm looking for T. So this means I can use the same equation, V equals to U plus AT. So 60 is equals to 0 plus 8T. 60 is equals to 8T, and T will be equals to 60 divided by 8, which will get me 7.5. And the units for time, seconds. Now part 2, I'm trying to find out the part where the race car decelerates. So I'll still start off with my Suvat. In this case, I still don't know how far did the car travel. What about my initial velocity? For the initial velocity, you can see that the start of part 2 is actually the same as the end of part 1, right? Because after it accelerates in part 1, it will start to decelerate in part 2. So the final velocity you got in part 1 is actually the initial velocity in part 2. So this will now be 60 meters per second. And the car comes to a complete stop. So our final velocity is 0. The deceleration is 8 meters per second. But remember, if it's a deceleration, you gotta include a negative sign. The time, that's what we're trying to find out too. So now, using the same equation, we're able to figure out that negative 60 is equals to negative 8t, and so t is equals to negative 60 divided by negative 8. It'll be the same time, 7.5 seconds. So the total time would be 7.5 seconds plus 7.5 seconds in part 2, which will be equals to 15 seconds in total. Now the third question is a little tricky. A rabbit and a tortoise are racing each other in a 100-meter race. The rabbit gives the tortoise a head start of 50 meters. The tortoise crawls steadily at 1 meters per second. As soon as the tortoise reaches the 50 meters mark, the rabbit starts running with a uniform acceleration of 0.5 meters per second squared. Who will win the race? Now you've heard of the tale between the rabbit and the tortoise, but this result might be different. So let's have a look. In order to do this question, you have to understand that the real race only starts when the tortoise has reached the 50 meters mark. Because while the tortoise was crawling towards the 50 meters mark, the rabbit is just standing there. It's just waiting. So nothing is happening to the rabbit. So we want to compare from the moment both of these animals start running to the moment where both of these animals reach the finish line. So we're looking at this situation down here at the bottom. So all we need to find out is how long does the tortoise take to finish the rest of the race compared to how long the rabbit takes to finish the whole race. And when we compare these two times, the shortest time would of course be the winner. So let's look at the tortoise. How far does it actually need to travel? Well, the moment the real race started, the tortoise only had 50 meters left. Its initial velocity is 1 meters per second, and its final velocity is also 1 meters per second. How do I know this? It's because it says that the tortoise is crawling steadily. That means its velocity doesn't change. So if the velocity doesn't change, the acceleration will remain as 0. Now, the time is what we're actually trying to find here. So, which equation can we actually use? Now, since we have S, U, V, A, we have a whole load of choices on what equations we can actually use. So, I'm going to use an equation that we haven't used before. We'll use S is equals to UT plus half AT squared. So 50 is equals to 1 multiplied T plus half 0 T squared. Of course, we know that anything multiplied by 0 becomes 0. So T is equals to 50 seconds. And what about the rabbit? The rabbit's distance is 100 meters because he starts exactly from the starting line. Its initial velocity is 0 because it was waiting for the turtle to reach the 50 meters mark. Final velocity is unknown because I don't know how fast the rabbit was traveling when it reached the finish line. The acceleration though is 0.5 as has been given by the question. And the time taken, again, that's what we're trying to find. So we have S, U, A while trying to find T. So our equation can be the same. S is equals to UT plus half AT squared. 100 is equals to 0 times T. plus half 0.5 t squared. So 100 is equals to 0.25 t squared. T squared is equals to 100 divided by 0.25. That'll give me 400. And a square root of 400 will give me 20 seconds. So, at this moment in time, where the tortoise has already crawled halfway, both of them starts to move and they start to follow the Suvat equations. The tortoise takes 50 seconds just to crawl this final distance, while the rabbit only takes 20 seconds to finish the entire race. So we can know that the rabbit will be way ahead of the tortoise. So it'll be waiting for the tortoise at the finish line. And that is all the examples we have for today. If you liked that video or if you have learned something, don't forget to like and subscribe. And remember to share this video with your friends who need it. I'm WeiEn Physics and I'll see you in the next video. Don't forget, never stop learning.